So good morning, everyone, and welcome to our third annual BioDesign conference. My name is Sandy Marshall, and I will be the moderator for today's session. And maybe, Julie, I'll get you moved next slide. So for all the attendees on there today, we very much appreciate your attendance. And I look forward to 2 good hours here. A little bit of upfront information here. All the attendees will have their cameras off and their mics will be muted for the period of the 2 hours. The chat room is open and we encourage everyone to use the chat room, as it is a good opportunity for you to share thoughts and ideas amongst yourselves joining the conference. So please take advantage of that. As moderator, I will be watching the Q&A section here. There is a Q&A button that is on the bottom of your screen that you can use and type in your questions into the box. I can see the questions that are coming up through there, and I will do my very best to take the questions that come up through the Q&A to bring them forward to our very good panel that we have today. And hopefully we'll have a good session on that. Next slide. So the BioDesign Group, our partners share a common vision of trying to leverage Canada's strengths to develop a Canadian bioeconomy. The group came together in 2017, and we continue to work to build a national network and a suite of resources that will enable Canada's bio-based industry to grow. To date, as I said, we've had 3 conferences. Today is our 3rd. Unfortunately, due to the COVID situation, this conference is virtual. 2 years ago, we worked to develop a strategy, a Canadian industrial bioeconomy strategy that recommended several actions, including more modern regulations, support for commercialization, better market access for bio-based products, and support for new businesses. So as we move forward here with the future of the BioDesign, a national bioeconomy ecosystem, we're working to develop a national bioeconomy ecosystem that will lead to the creation of new and stronger value chains, leading to more anchor companies and more Canadian products that are entering the global markets. The context for our conference today is how the Canadian industrial bioeconomy can help to transform Canada's economy. The world's economy has undergone a significant disruption here in the last 6 to 9 months. And prior to that, and we were very focused on a lot of the changes that are coming through the impact of climate change that continue to pose an existential threat to society. Many countries are embedding low carbon and circular economy principles into their economic recovery strategies. And we believe that Canada's competitive advantage of access to biomass and skilled labor and others can be leveraged to improve our economy, and while at the same time responding to climate change. The panel we have today is focused on leveraging biomass for sustainable products. Description is written here, and it is really about focusing on promoting the highest valorization of Canadian biomass, while at the same time supporting a reduced carbon footprint and effective stewardship of our natural resources. It is the development of this bioeconomy that is a platform that helps us to integrate the bioeconomy into the circular economy. And the benefit for Canada is clearly the development of a more sustainable economy, supported and particularly focused in rural areas through the creation of high-skilled jobs. The panel today we have is a very illustrious panel from across Canada and around the world. Our first speaker today will be Stephane Renou, who's the President and Chief Executive Officer of FPInnovations. We also have Bill Grill with us, who is the Chief Executive Officer of the Proteins Industry Canada out of Saskatoon. Stephane is out of Montreal. And Our third speaker is Dex Zhu. He's General Manager and New Business Development Manager for LCY Biosciences, located in Sarnia, Ontario. And our final fourth speaker is Joop Gruen, who's a member of the Executive Board with the Circular Biobase Delta out of the Netherlands. With no further ado, I would like to move forward into our panel today and introduce Stephane Renou. And Stephane, I'll let you take it from here.
Right, thanks, Sandy. Glad to be here today. So another wonderful day of working from home for me, like many of you, I'm sure. So let's start this presentation today. I have the privilege to be the CEO of FPInnovations since 3 years, and it still amazes me to see the world of possibilities we have in front of us. So if we can go to the next slide. So, you know, the forest industry, I mean, we tell that it's growing for the bioeconomy. It's actually a phenomenal source of raw materials for the bioeconomy to be developed. It's an industry that needs to be changed to get there. We need to move from a traditional forestry, traditional wood product making and paper making to evolve all that supply chain, which is well integrated together, and push it towards the bioeconomy. So get to extract all those molecules one at a time. What's phenomenal about the forest industry, it's actually a key solution for 3 major prongs. Every time we grow the forest industry, we create economic growth, of course. We also help to find solutions for climate change. Every time we use a molecule from the forest, we don't use it from elsewhere. So it's always a positive. And finally, it's also helping promoting regional development. So those 3 prongs move all together at the same time when we grow the forest industry. It's an extremely well-integrated industry. From gardening trees, harvesting trees, you will create construction materials, and from the residue of construction materials production, you will get into pulp and paper and then bioproduct. It's already extremely well integrated. It needs now to get integrated to the next level to go really integrate all those other supply chains to create this circular economy that we all dream of. Little word on the environmental impact. I'll talk a bit more in the next slide, but it's actually 3 important prongs there. The more we use the forest efficiently, the more we use the forest in a sustainable manner, the better it becomes a carbon sink, which is really important for the addressing any climate change challenges. Every time you use wood as a material, it becomes a carbon capture mechanism. And finally, every time we use fibers or molecule from wood, we can substitute other material coming from other sources that are less carbon friendly. But the bottom line in all of this, it's all about economics. Whatever dreams we have, they need to be sound in economically. It needs to make sense. Investments need to make sense. The difficulty we have is to combine the normal today's market economics with the economics of tomorrow, which will be probably based a bit more on carbon. It's a choice to make. It's an opportunity as well. Next slide, please. So if you look at the forest proposal, right, I was thinking about the 3 prongs in terms of helping the challenge of global climate. The carbon sink. Every time we harvest the forests correctly, every time we manage the forests in a sustainable manner, we help create this carbon sink that can be used to help meet our targets. It's about intensifying the forest, do it reasonably, having access to that fiber. Those are the key needed conditions to make that carbon sink a reality. Carbon storage, every time we construct with wood, every time we are more efficient doing so, every time we industrialize construction and bring more wood product, advanced wood product, the better we increase that carbon storage capacity. Substitution is the big challenge ahead. How do we use molecules coming from natural source to substitute molecules coming from other source? How do we create that market value? How do we make sure that it makes sense economically? And how do we integrate channels that are used to easier to use molecules? But the key to all of this is really look at everything we harvest from nature, whatever source we use, and make sure we use every molecule. It's in the efficiency of usage of the natural resource that the magic relies. Next slide, please. All right, so thinking traditionally for 1 second, right? So I think several of you are well aware of what's happening in the pulp and paper industry. To start from there, We use fibers. They could be for a chemical pulping approach, they could be for a mechanical pulping approach, but all those fibers, those cellulosic filament and all deviation of, can be used in traditional product. Film, packaging, paper, wood fiber, composite, wood panel. We know that word well. We can be more integrated. We can push more new product and develop new application, especially in the packaging space. Using more and more paper-based product or fiber-based product is an advantage to replace plastics. So there's a natural push we can do there. But if we go a bit deeper here, let's think about what we can do from a market development perspective. Next slide, please. So here, we'll talk to you about a challenge we took this summer. I mean, during this COVID crisis, we're all aware of the challenges of getting masks. Masks are mainly produced from petroleum-based product. So we put the challenge on the table this summer with the help of our friend from the government and Arcan especially to see, can we do a mask made out of natural fibers? What will that mean? And if you look at the incumbent, which is the two pictures you have at the top of this slide, it's actually typically material based out of polypropylene, polyethylene, different variations and form, but it's basically a plastic material which is processed through a not the best environmental friendly process, shall I say, to be nice, but it does bring some interesting capacity. Plastic can be melted, so they can create structure that are interesting. So on the left side, on the top, you see the filtration media, which is kind of this percolation labyrinth of polymeric fibers that retain particles. And can see on the right, a more physical barrier that just holds the mask together. That's that blue layer you see in a surgical mask. So through the summer, we actually play with those two layers, try to figure out what can be replaced. And we have also integrated into a manufacturing chain the production of the filtration layer. So that picture from the right, we can make it out of natural fibers. We can make it in a product. That's what you see at the lower right corner here, where that filtration layer is actually made out of natural fibers. Next steps are what? Do the external fiber. We can go back to the last slide in a second. Doing that blue plastic layer is a challenge that we need to look at. But also through the product development, we need to realize doing it in the lab is never good enough. Certification, productization are the key challenge forward. And changing the incumbent doesn't just mean replacing a product. It also means adapting regulation, adapting certification, so we make sure it's not biased toward one product or the other. That's the key challenge here. Next slide. So if we go deeper, I take those fiber, I decompose them chemically. Well, then you have this explosion of possibility that my fellow participant to this panel will talk in a bit more detail, I'm sure. But you have this explosion of chemistry. So on the ligand side, we have this fantastic molecule that can be decomposed in small pieces. Some can be used in bulk to put in asphalt, to put as a filler in polymers, to be transformed in additive. Some extremely specific part can be used directly in the supply chain of pharma or other specialty molecule businesses. It's a phenomenal molecule, but to be efficient, once again, one application is not enough. We need to use each part of the molecule efficiently, which leads basically to biorefineries. How to decompose the molecule and use each segment in the best efficient way. One application is not good enough from an economical point of view. Same with sugar. A lot of possibility of chemistry here. It's a phenomenal molecule as well. Can lead to several precursors. But for all of this to make sense, it needs to be all integrated economically. Each of those prongs will probably not make it alone, or it will be difficult. It's about integrating the complete supply chain from the fiber of wood directly down to all the possibility of molecules and insert them everywhere at the same time. Next slide. So just a little example of what's possible here. So on the left side, you have a natural fiber. We've been dealing with this fabulous fiber for a long time. We know different species of wood. We know different composition of those, the chemistry of those species. We can play with it to make paper, towels, every kind of material. When you start to decompose it a step further and get into that ligand, that cellulose, you can actually rebuild fibers. That's what you see on the right. Those fiber you see are pure cellulose that are all built with simple chemistry, simple industrial process that can be done at high speed in industrial compounds. Then those can be processed by the market. So it's all about recreating materials that are more tailored for an industrialization in other markets, change those fiber, modify them, add properties to them, and really tailored the chemical and physical properties of the material of the future. So it's engineering of materials that can substitute in current application or create new ones. Final slide. So this is a challenge we have ahead of us, all of us. Everybody always look at Silicon Valley, this fabulous concept, and we just need to recreate it. Here's a bit of a challenge on the bioeconomy side. It's not as simple as software. It's not as simple as electronics in the 80s or 90s, where everybody can do stuff in their garage or basement at low cost. It's a capital intensive industry where moved request a lot of capital investments. So we need to focus, we need to harness resource from everywhere to make sure we have critical mass to be successful. And that's a bit of the challenge we all have. One application doesn't cut it, or it's difficult. Several examples out there. So how can we focus across the government, the scientists, the industry, the investor on the few approach that make it happen? It's going to require working together to co-creation, get IP to flow a bit better, to be able to create that critical mass that enabled the first big market application. And on this, Sandy, I close.
Great. Thank you very much, Stephane. I've had a couple of little difficulties here myself where my internet has dropped me off. So I'll just warn, if I happen to disappear and not be available at a moment when I'm supposed to be moderating, I'll be scrambling to get back on. So please bear with me. So next slide, please. So I'd now like to introduce our second speaker. Bill Gruel is the Chief Executive Officer of Protein Industries Canada, which is a supercluster centered out of Saskatoon, Saskatchewan. Over to you, Bill.
Great. Thank you so much, Sandy. I was listening to Stephane speak, and I've had the great pleasure of working in the agriculture sector my entire career, and I just thought about this talk is really about the evolution of what agriculture is going to contribute to the bioeconomy, because we used to think about it as the conversion of waste streams, which was flax straw or wheat straw, into something for the bioeconomy. Not an overly successful venture in Western Canada for a number of reasons, but I think we're on the cusp of something new as we look toward value-added processing. So today I want to speak a little bit about agriculture as a sector. I want to talk a little bit about the work that we're doing at Protein Industries Canada, and then introduce this concept of the evolution of the agriculture sector from where we used to think about contributions to the bioeconomy to the contributions that we truly can make to the bioeconomy today and into the future. So next slide, please. I always start my talks trying to ground the audience a little bit in agriculture, and I never shy away from that, because agri-food is the largest employer in Canada. It is the second largest contributor to GDP, and outside of the borders of Western Canada, people don't always realize the scope and scale of the sector. Here in Western Canada, it's a really very exciting time of year. We're just getting into harvest. We're about 20 to 25% done. Yields are very good. And this is the annual time of year where we're taking crop production off of 28 million hectares of arable land. Most of the pulses are off right now. Western Canada is the largest pulse exporter in the world, the #1 producer of lentils and peas, the world's largest producer and exporter of canola. And it's, like I say, a very exciting time of year. And the next slide helps put this into context a little bit. Annually, we produce about 69 million metric tons of crop production in Western Canada. And you can see the breakdown of the crop base. I think what's important is to start to recognize the scope and scale of the contribution that agriculture can make to the bioeconomy. So we are, of course, Protein Industries Canada, but I really want to make the case for total crop utilization of what is critical for us to get right in Western Canada. So on average, we're sitting on about 14 million metric tons of protein. And so if you go to the next slide, this kind of sets the context of why Protein Industries Canada was created. We view and want to see Canada as a world leader in plant protein. We are one of Canada's 5 innovation superclusters. We invest collaboratively to accelerate innovation and competitiveness across the Canadian plant protein sector. But the reality is we should really be called Total Crop Utilization Industries Canada. It's not a very catchy name, but I just want to ground everyone in the fact that what we're chasing is the global growth in plant protein. What we have to get right and what we have to monetize and what we have to completely utilize is the starch and fiber components as we strip out plant protein to meet that growing global demand. It's very critical for us as we think about growth of the sector in terms of how we will utilize those co-products in the bioeconomy. And I'll talk a little bit about the evolution of those co-products to get us thinking beyond where we used to think in agriculture in terms of crop residue and crop waste to where we can get to, which is highly purified components that can be utilized in the bioeconomy. So maybe the next slide, please. This just talks a little bit about our approach. So as one of Canada's 5 superclusters, we are investing $300 million over the next 4 years to transform our value-added processing sector. You think about the slide I talked about before, the 69 million metric tons of crop production we produce in Western Canada on an annual basis. Generally, we're exporting the vast majority of that as whole seed, and other countries and other jurisdictions globally are doing value-added processing and capturing that value. We do process about 50% of our canola crop, but even at that, we're exporting relatively high-value oil, but relatively low-value meal, which can be a good source of components for the bioeconomy. So we aim to create connections and collaborations among private sector companies and agriculture research institutions. And we really believe that a different approach to doing business will lead to enhanced innovation and GDP and job growth in the agriculture sector. So the next slide talks a little bit about what we would call our investment thesis. We understand full well that to get to the end game, which is processing a higher proportion of the crops that we produce today, that we need to make investments along the entire value chain and create projects that put together organizations within different verticals of this value chain. So we invest right from plant breeding work under CREATE to production agriculture, a lot of digital support systems for improving efficiency and building out traceability and chain of custody type work. The largest portion of our investments is what we would call MAKE. That's the development of new and novel processing technologies and better co-product and waste stream utilization. Because as I say, the growth of the sector will only be profitable if we are creating the maximum amount of value out of the co-products in the waste stream. And finally, we invest in what we call the cell category. At the end of the day, what we're doing at Protein Industries Canada is really a pure export play for us. We export 90% of the production that we produce today. That scenario likely doesn't change under a value-added processing sector. Large geography, small population base, one of 5 jurisdictions globally that's a net exporter of food. To be highly focused on consumer needs is really critical for our sector. So the next slide talks a little bit about, I want to dig into this concept of the MAKE category, because really this is what will push out different high value inputs for the bioeconomy. So we're doing a lot of work now with processing companies developing new and novel processing technologies to extract oleosomes or high value protein concentrates and isolates. But really what that leaves us with is a growth in starches and fiber. And I'll talk a little bit about why that looks different today than it used to maybe look in the past. So the next slide, please. You know, for Canada's crops, you know, starch is a bigger portion than protein. And so again, I go back to we are Protein Industries Canada, but we really need to think holistically about what it is we're doing. The work that we're doing in pulses and cereals, for example, starch makes up 2 to 7 times more than protein. So we really have to think about the starch and fiber components as something of value as opposed to something of a waste stream. And so in order to extract that maximum value, we really need strong applications for fibers and starches, just as we do for plant protein. So the next slide, please, that really just grounds us in terms of what is the value that we're talking about here. So in 2019, Canada produced just north of 4 million metric tons of peas. And we expect to see about a quarter of that to be processed in Western Canada with the coming online of large processing facilities like Roquette, the work that Verdient is doing in Saskatoon, a couple of processing facilities under construction. I think this is a really telling slide, though, of the value that agriculture can contribute, not only to the growth of the agri-food sector, but also the bioeconomy. So 1 million metric tons of peas, average price, $250 a metric ton. You can all do the math. When we get to a stage of value-added processing, certainly the pea protein concentrate and isolate is going to be the lion's share of the value. We think on that for, you know, average price of $4,000 per metric ton is not unreasonable. But then you think about the cost of product procurement, the cost of capital to create those isolates and concentrates, really the value of the crop is contained in those co-product streams. I don't like to term them as waste streams. I want to say co-product streams. So that million metric tons leads to 500,000 metric tons of pea starch and 200,000 metric tons of fiber. That's additional almost $400 million of value if we get it right and capture it. So the next slide, please. I think this really drives home the evolution that we're going through here. I think I created this slide and I started with whole seed at the bottom. I think if we think about the evolution of the agriculture sector and the contribution to the bioeconomy, we should probably be starting with something like crop residue. That's how we used to think about agriculture's contribution to the bioeconomy. But as we move from whole seed to dehulled seeds, to pulse flours, to protein concentrates, to protein isolates, what happens is as you're separating and purifying protein, oil, and starch, the fiber content and the starch content is significantly increased. It's much higher in terms of its purity. The crops that we're producing in Western Canada have some unique properties for the fiber and the starch, and we end up with very high value compounds that can be used for the bioeconomy. So the next slide then opens up how those products could be used. So this looks very different than it would have even 5 or 10 years ago in terms of how we view the co-products of value-added processing to be utilized as inputs into the bioeconomy across food uses, feed uses, industrial uses, and medical uses. So I'm getting a bit close to the end of my time. So maybe the next 2 slides I'll jump through relatively quickly. This is the type of co-investment that Protein Industries Canada is making. I just want to highlight a few things. I think it demonstrates both the approach we're taking as investments in the value chain, putting AGT together, which is a processor, together with Ulivit, which is a consumer packaged goods company. So it just talks a little bit about the type of work that we're doing in the utilization, but a project like this, which is AGT Food and Ingredients out of Regina here, will lead to a high volume of not only starches, but a high volume of fiber, because the first step in the processing is the stripping away of the seed coat. And so the next slide talks a little bit about the type of projects that we're funding that would be of interest, I think, maybe to the people on the call today. We put together AGT Food and Ingredient with a company out of Vancouver, BC called Lucent Biosciences. They're using the fiber that's stripped off in the dehulling process as the first step in the creation of ingredients and consumer packaged goods at pulses as a carrier for micronutrient fertilizer. Lucent started out this work using coconut husks and hulls, and we're converting them to a co-product stream utilization that we have available for us here in Western Canada, just as an example of the type of work that we're doing. So the next slide just really highlights what we think are some of the research and investment areas. I'm happy to share this with anyone on the phone, but I think I've probably reached the end of my time limit. So I'll just leave this slide up. You can get a sense of what we're thinking about in terms of R&D investments. As we look to the future of Protein Industries Canada, I will admit some of the first investments and the largest investments we've made have been around extracting protein and making sure we've got that part of the equation right. I think as we look to the future, maybe to a re-up of funding, the next iteration of Protein Industries Canada, our next call for projects, we really need to think about co-product utilization and the better utilization of starch and fiber, because as I say, if we don't get that one right, we won't have the total value extracted. So Sandy, I'll end my comments there, and we can move on.
Our last speaker, Joep Gruen, from the Netherlands. He is part of Biocircular Delta, our Circular Bio-Based Delta, which is a group that we have worked with at BIC for many years and have very strong relationships. They have been an excellent partner, and we share a lot of the same values and approaches to the development of green and sustainable technologies. With that, I will introduce Joep Gruen, who will give us some insight on the activities that are going on in Europe, particularly around bio-based delta. And so over to you, Joep.
Yeah, thank you very much, Sandy, and I'm glad to make a contribution from the other side of the pond. And yeah, as you said, there is quite a long-lasting collaboration between our geographical areas, but also, for instance, there's more emotional ties between Canada and the region here. We are in the southwest area of the Netherlands, and for instance, just 5 kilometers away from my home, there is a large Canadian war cemetery, and it's very well kept, and it's a special place. So strong ties between our areas. I call this pitch acceleration by collaboration, because we see that in many of the initiatives, collaboration is quite key to success. So I want to zoom into that a little bit. If we go to the next slide, tell a little bit about the contents, introducing Circular Bio-Based Delta, so you all understand who we are and what we are doing. Then give a couple of specific examples. One about bio-based procurement, one about shared research, more high-tech, one about bio-based asphalt, very much applied. And then, you know, if we reflect on that, what conclusions can we draw? So let's go to the next slide and look at the Circular Bio-Based Delta. It's an initiative with a number of stakeholders, some from large companies like Cosun, the sugar company, RWE, the energy company, Cargill, I think, especially in Sarnia, you know quite well, and companies like Sabic Petrochemical. Then there are a number of provinces as stakeholders, South Holland, Zeeland, and North Brabant. They are the three southwestern provinces who joined forces to make a joint circular and bio-based strategy. We have a number of investment funds and knowledge players like TNO, Wageningen Research, and Center of Expertise Bio-Based Delta. If we go to the next slide, then you can see that the main roles that we are playing is to identify opportunities, you know, connect people and organizations, facilitate progress, monitor, and you know, inspire. On top of that, we do some lobbying and try to influence to move into the right direction. In order to do that effectively, we build up a strong ecosystem of you know, top locations. They can be campuses like the Green Chemistry Campus or the Biotech Campus in Delft. We have a number of application centers, for instance, for natural fibers, or we have an application center for bio-based polymers, for bio-based colors, so various expertise in various application centers. Then we have the knowledge and educational institutes that collaborate strongly in that. We have 3 deep sea harbors. As the Netherlands, you may know, we have a small surface, so we don't have a lot of local production of agriculture, but we like to harvest from our harbors, and then we have access to the world of, you know, supply and demand, which is quite effective also for, of course, bio-based feedstocks. And we have industrial parks. So if we go to the next slide, that shows the first specific example, which I called here bio-based procurement in the Netherlands. I wanted to use the images of these initiatives, so and they are in Dutch, so you see some Dutch information here, but the examples are, I think, very clear and specific. On the upper left, you see a new tool that we have developed. It's a database of bio-based products that can effectively support the procurement processes. Apart from the database itself, we put in an, you know, like a governance structure to make sure that it is maintained and used over the long term. On the upper right-hand side, you see an initiative by the province of Zeeland, who just very specifically stimulates this bio-based purchasing. And they look at categories, you know, like wood, plastic, textile, paints, isolation, lubricants. As a province, they are purchasing a lot, and this way they can influence, you know, without just putting in a lot of money, but being a launching customer, stimulating the market, growing the market, and that's very effective. In the middle, you see the piano system. That's a national Dutch procurement system, and in that procurement system, there is a specific chapter about bio-based purchasing. So it's also an example of how you can help stimulate this. And on the bottom left, there is an initiative of the National Bio-Based Economy Organization that is also stimulating sustainable purchasing, for instance, for cleaning agents, packaging, raw materials, you know, separating waste, various ways of achieving and stimulating the bio-based economy. If we go to the next slide for the next example, this is Biorizing, very different nature, but also quite successful and effective. Here it is all about shared research for bio-based aromatics. So 40% of everything we see around us, paints, polymers, chemicals, are aromatic by nature. So this is a very important class of chemicals to convert to bio-based. At the moment, it's all petrochemical. Well, how do we do that? If we go to the next slide, we can see that the Biorizing program, which was initiated in 2013 after a careful strategic planning, has evolved in 3 major program lines. One line is sugar to bioaromatics, where we use furan and Diels-Alder chemistry to very high purity specialty bioaromatics, like, for instance, hemimalitic acid. In the second program line, you see lignin to bioaromatics. So there we use the lignin fraction, catalytically depolymerize it, and then separate and purify the fractions, and apply them in various applications. And the third program line is geared towards thermochemical conversion, pyrolysis and gasification of biomass residues, and also lignin. And that gives more bulk aromatic products, which because of this co-production, typically there we have a co-production of fuels and chemicals, which can be quite cost effective. If we go to the next slide, we can see that since we are, quite a number of years on the way, that we see that the various technologies have reached pilot stage. So where we begin with, patent research, initial work in the lab, milligrams, glass work. Now we are in the phase of stainless steel. You see here, this pilot has been realized by Zeton, a Canadian-Dutch company, by the way. And we are now at the stage where we can make tens of kilograms of the most successful products out of the initial stages. And also, therefore, we are focusing more and more on the application and market development. If we go to the next slide, then you can see that what is a very important aspect in the BioHorizon Shared Research Initiative since the very beginning is very close collaboration with the industry, with knowledge players. We do that through our BioHorizon community. If you are interested in this, you are most welcome to join the community. Go to biohorizon.eu community and join, and you can have a number of benefits in this area. If we go to the next slide and the next example, this is called Chaplin. Maybe because I thought it was a catchy name, but you can also say it stands for Collaboration in Asphalt Application with Lignin. Initiated by the Circular Biobase Delta just 1 year ago. The main objective there is to find another application for lignin, added value application, to green the industry of road surfaces, and at the same time to help improve the business case for biorefineries that have lignin as a side product. Now, how are we doing that? You can see at the next slide. What I did at the very beginning of this program is look and visualize the value chain and start talking to players at the end of the value chain. But this kind of value chain approach, normally it helps a lot if the end of the value chain pools and gives direction. In this case, that worked out quite well. We have a number of provinces. We have the National Department of Waterways and Public Works, and we have a number of municipalities. They all own roads, so they can help give guidance and priority to these activities. Then we have a number of asphalt and road builders, big ones and small ones. We have lignin suppliers, a number of them you may recognize, some international big ones like Praj, but also some new technologies like Avantium, who have a very different type of lignin. And we have a number of knowledge suppliers who collaborate in this consortium, like University of Utrecht, Wageningen, TNO, or the Asphalt Knowledge Center. If we go to the next slide, why do we think Biobase Delta is successful in organizing this kind of program? That there's a good motivation at the stakeholders. It's important for greening the industry and achieving CO2 reduction. Also to improve the business case and to stimulate economic activities in the region. Next slide, please. Why do we think collaboration is important? Because, if you want to get something done and you can do it bilateral, I would always prefer that because it's quicker and more simple. but you know, some challenges are too big, and you need multiple players to get it done. That's typically the case for you know, successfully using lignin in asphalt, but for instance also for this bio-based aromatics program. Their smart collaboration can accelerate development and commercialization, and it helps to have a reputable independent player to organize such collaborations. So independent of the value chain and not having one specific objective other than just get success for all of the players. Why is this collaboration so effective? That's because sharing experience, knowledge, facilities, you know, financial burdens, but for instance also sharing risks makes it a lot more effective. And the vision of a group like this is also a lot stronger than the vision of one of the individual players, because together you're just smarter. Next slide, please. These are some examples that we have achieved in the meantime. So lignin actually applied on the roads, initially just on the top layers of the roads, and this month we're going to the middle layers and the foundation layers of roads to also apply lignin-based asphalt. And in each test strip that we realize, you know, we learn more and get more valuable data. Next slide, please. So some of the conclusions of the experiences that we have built up as a circular bio-based delta over the last almost 10 years already is the successful transition to circular bio-based delta is much more a marathon than a sprint. You know, it's endurance, it's hanging in there, make progress every day, and you know, see that we move forward. Collaboration, we think, really is key to accelerate. Triple helix collaboration, as we call it. So that's the industry together with the government and together with the knowledge players. But for instance, also collaboration, as we've seen in the example of Chaplin, along the value chain. There are many opportunities, and they are very diverse of nature. You know, I am not a big fan of saying this is more important than the other thing, or, you know, this transition is so important. We need all of these initiatives, and, you know, we will find out which ones are more effective and most successful and catalyze and stimulate them. The government certainly can play a very stimulating role and a very positive role in this by a number of ways, and certainly not just by subsidies. Next slide, please, to end this presentation. If you are interested, here is my contact information, so please feel free to reach out and contact us. If you feel you can add value to any of these initiatives, you are most welcome to join in one way or another. There are very different ways that we can collaborate, so together I'm sure we can find the most suitable way. With this, I would like to end my contribution to this conference, and I think we will stick around for some Q&A.
Thank you, Jo, and thank you to all of our speakers, Stephane, Bill, Dex, outstanding presentations, and I think it sets the stage for most of the next hour, where we can get into some Q&A. There's been a lot of questions coming in, and there has been some answers provided directly back to certain questions from the individuals who were being specifically asked, and I think that works very well for some of those very specific questions. I think I'd like to try and dive into some of the common themes that have came up. The speakers have touched on a number of things, and I would like to get a bit of a broader perspective on some of those themes and expand it across the group of speakers. There are still some specific questions coming in that I will try to get addressed over the course of the next hour. So I think since one of the themes that I think came out of the last presentation particularly as it relates to some asphalt and products, is I think the potential for procurement policies. And when I think of asphalt and maintenance of roads, these are responsibilities generally of our government works. And I just wanted to get a view from the speakers of is there, or what is the role for government procurement in being able to move the bioeconomy forward? And so maybe I'll just, I think Joop had spoke to that. Maybe I'll let you speak to that again if you've got anything more specific to add around government procurement policy, and then I'll move on to the some of the other speakers. Thanks, Joop.
Yeah, sure, Sandy. I think that role really can be very important and very effective. And maybe starting from the situation where the government is a player in the value chain. So actually is, for instance, can be a launching customer or can be influencing the size of the market. If you look at the volumes that various governmental organizations actually are purchasing, they are humongous, and that's an effective way of influencing. Of course, the other way is by policies. For instance, this can be the own policies of rating various products. So, for instance, putting the emphasis not only on price but also on performance, and making sustainability part of performance. That can be very effective. And then, of course, also in legislation, as soon as something is clearly an important and successful solution, this can also be frozen. Some very successful changes that I've been involved in myself in the past is from a very different industry, but I think it's a nice example, is, for instance, automotive, and how the pollution from the exhaust has been driven down and down and down by setting policies. Here in Europe, that's called Europe 1, 2, 3, 4, 5. At the moment, we are, I think, at Euro 7, and that's also been quite effective.
Great, thank you. Stephane, do you have a comment here?
Yeah, absolutely. Actually, I agree with everything that have been said so far. I think government have two major prongs to help. Policies and procurement are probably the key one. We always look at the government to subsidize capital or first investment, but providing market is a much more effective way to reduce risk when you look at it. Creating that first market is just reducing the overall investment risk, increasing the ROI, and that's a much more effective way to stimulate the market. Policy is a question of choice, will change with government with different political direction, but procurement for sure is effective. Just look at what happened on the wood construction, how you can change technology by stimulating wood construction. If the government start buying those hospitals, those schools, and force a certain wood content, it drives the entire market one way or the other. Same could happen on replacement of plastics, on any molecule from protein to sugars. That's a key way to act, which is not costing the government money other than what it was going to spend anyway. So it's the best of both worlds.
Great, thank you, Stephane. Bill, I'll pass it on to you for some comments.
Yeah, I don't know that I have much to add, Sandy, other than it's an interesting concept about the alignment of objectives of government. If you think about the contribution that both the forestry industry that Stephane talked about and the agriculture value-added processing sector that I'm involved in, we've got an ability to grow them from an economic perspective, but also to achieve, I think, overall government policy objectives of, the greening of the economy, reduction in plastics. So I think, I would agree, but what makes it really attractive, I would say, for government is the alignment of the policy objectives around sustainability and our climate change goals in Canada.
Great, thank you very much. Dex, do you have anything to add here at this point?
Yeah, I think I can really very quickly to share from our point of view. we are, okay, take biosuccinic acid as an example. This market is actually highly driven by government's act and their regulatory point of view. Let's put this way. So everybody have to notice that most of those plastics, I'm talking about polypropylene or other stuff, they are actually produced in multi-million tons per year. So no matter how good your fermentation technology is, your green chemical is going to be a little bit more expensive than others. It's going to happen. And in this case, if you are going to push this market, for example, in Asia, mostly in Europe, some governments started to discuss, hey, we need to get this plastic reduction, one-time use plastic down. And when they release this kind of information and they put their procurement, for example, in my country, in Taiwan, government cannot purchase one-time use straw in government department anymore. So they can only use either glass or metal ones or biodegradable polymers. When you have this kind of information sent out by government, consumers will now consider some more expensive choice and then move to green process and green chemical. This is like right now the most biggest driver of the bioplastic market from my point of view, because in the end consumer product, it's all about the consumer experience price, and then can you use it or not by government regulatory. That is a quick comment about this topic.
Great, thank you, Dex. And I'm going to move on to a next question. And since there's a couple of questions here interested in biosuccinic acid, which I think align a little bit with what you've just talked about. The first question was, what percentage of your biosuccinic acid production produced is consumed domestically? Or I guess the other side of it, how much of it is exported? And if you're able to kind of give us a sense of where it's exported to and potentially why.
So as discussed, this is highly affected by government regulatory stuff. So our product, like 100% actually exported. None of them, or like few, like 1% or like much less than 1% are sold in Canada, because only one or two like startups, they are just starting to test it for this bioplastic. Majorly, our customers purchase our product to Asia and then make bioplastic and then sell back to Europe. That is the major market is. And I think it's mainly because in Europe, one-time use plastic is right now the major issue, and they have a lot of government and regulatory already addressed that. And therefore, most of the bioplastic market is right now actually there.
Very good. Thank you very much. So Bill, you touched on this a bit around the role of the bioeconomy in supporting or enabling increased profitability of the agri-food sector. I'd like to kind of touch on that a little bit more amongst the group. I'll maybe start with you, Bill. You've already talked about that. Is there a point you'd like to put in here at this point before I go to the other speakers?
Yeah, nothing more than just how critical it is, Sandy. So like when you think about what we're trying to do at Protein Industries Canada, for every metric ton of plant protein we produce, we're going to have a multiple factor of starch and or fiber. And so, you know, and all of that needs a home. It all needs a home, be it the livestock industry, the biofuel industry, as feedstocks for the bioeconomy. It's a really critical piece to the overall profitability of what we're trying to do here. So just to level set on the critical nature of getting it right.
Okay, Stephane.
All right, fighting with my mute button a little bit. Well, listen, everything we touch circular economy of the usage of all stream is paramount. At least if you look for 1 second at the oil industry, to name it, if you go in a refinery, every molecule out of the oil will be used and monetized. So we're already fighting thermodynamics sometime by cutting in pieces molecules to go to the bio-based chemicals that we need. So using everything in a circular way is going to be the way to make everything making cost sense at the end. So that will be my comment.
Great, thank you. And I'll turn it back to the circular bio-based delta for some comment here as the intro here.
Yeah, I think what is good to realize that also the playing field is changing as we learn more, as regulations change, as technologies change. For instance, if you look at the sugar beet industry in our area here, we also have a fairly large amount of sugar beets being processed, and there typically it would be the main product is sugar and the rest is cattle feed. And at the moment, we see that also there, the business case of refining it more precisely and creating, for instance, high-end proteins out of those streams become very interesting and very viable. I think it's also good to be aware that this you could see with the example of lignin, where some people tend to think, well, you know, I want to apply my lignin as high as possible, so let's depolymerize and go for the high-end applications north of $2,000 per ton. But there are always different fractions, and even if you start processing the sugar fractions, you get some humins, and all these fractions need to be valorized, and we need to learn in which applications and under which conditions to do that. I think that by itself is very important and very valuable.
Okay, very good, thank you. There's two questions that have came in that I think you can quickly answer here. You commented on the use of lignin. What are the expectations for the use of lignin on roads in Holland within the next 5 to 10 years?
Yeah, I think it will grow. It will grow a lot because the application looks quite promising. The results of the test strips come out, you know, quite promising. And remember that it's all about, in the end, performance. If you can create a road that has a longer lifetime, that's very, very effective. It's effective in sustainability and it's effective in economics. Then, for instance, if you can lower the rolling resistance of the traffic using those roads, that is very, very effective in the economy for the consumers, but also very effective in CO2 emissions, because the CO2 emissions caused by, you know, by the exhaust is much more effective and stronger than the CO2 emissions caused by the material and the process of putting the road in place. So I think there's some very, very interesting opportunities there that we have only just started to scratch the surface. Did that answer your question, Sandy, or only half of it?
No, I think they were looking for some sort of number, but that might be a little difficult for you to project at this point in time.
Yeah, what I can say in numbers is at this moment we replaced 50% of the petrochemical bitumen by lignin. And our focus is just to enter the market with this 50% more than to grow it to 100% off the bat. But we do see opportunities for future increase to 100%.
Very good. And a quick question here: what percent of the funding for bio-based? What is your funding model at Bio-based Delta relative to government and industry partners?
It's about 50-50 for the base funding, so for our base program annual funding. And then we have some funding structures that are by program. You know, like for instance, the Chaplin program that's mainly funded by the active participants in that program.
Great, thank you. So Stephane talked a bit about some of the reshoring, particularly around fiber for COVID masks and this sort of thing. I'd like to maybe talk a little bit about reshoring some of our supply chains, obviously if we're basing on biomass, but then probably more importantly is reshoring some of our value chains. And I would like to get some thoughts from the panelists on the impact of that, or the opportunity in that, and potentially what impact that might have on GHG reductions. Maybe I'll start with Stephane, because I think you made the first comments about the fiber for masks.
I mean, reshoring is an interesting topic. So what can be done, where, how? So I can talk a bit about the mask in a bit more details than what I answer in the question. The material we got, we can have, right? I was saying in my answer, for instance, that producing just the filtration media en masse can be done at the rate of millions of filtration media or millions of mass per paper machine per day. So we have that part. It's all the other parts that we kind of let go offshore quite a bit. The actual machine that transform that material into a final mask, that it's not in Canada anymore. So it's just a reinvestment, but it needs to make sense. And it needs to make sense at an automation level that is appropriate for us to be able to be competitive. So I think there were some comments about, I mean, is COVID changing a little bit the way we think about green now, from safety and security, about supply chain? Yes, it does. There's going to be a bit more of centricity of countries to produce in-house that will move the cost point, as well as an evolution of the pyramid of Maslow in terms of what people want and what they care about. So we're shifting. That's how we're going to answer it. And reshoring will be driven as much about nationalistic instincts as how can we create a cost point that makes sense. And that's going to be for Canada for sure in terms of automation level we can get to.
Great. Thank you. Bill, do you have some thoughts on this?
Yeah, it's interesting, and it's certainly this idea of supply chain disruption and domestication of the food supply came to a head, of course, through COVID. And so, you know, I'm thinking a little bit about it in terms of food systems, but that does have follow-on effect for us as we think about the utilization of co-products for the bioeconomy. It's an interesting and delicate discussion for, I think, the agriculture sector, because we are in Western Canada export based, and we always will be, just because of the fact that we've got a low population density and a lot of land. And so, you know, the idea of food sovereignty is an interesting one for us as we think about that, other nations thinking that through. But, you know, in terms of how we're doing this, utilizing co-products for the bioeconomy, I think there is a real opportunity here as we increase value-added processing for protein and export that as a product. It does lead to a large feedstock that we can use for the bioeconomy. So I think, you know, the issues and challenges around supply chain disruption that have been brought to a head by COVID won't be going away, but it does present us an opportunity, I think, again, for the better utilization of the feedstocks that we're producing for co-products.
Very good, thank you. And I'll go to Dex now. You know, maybe, you know, you're a Taiwanese-based company that's came to Canada and taken an asset that's here. And now you are building out here in Canada, but yet as an international company, you have an opportunity to go anywhere you choose to go. I'm curious to hear your thoughts about the Canadian space and the thought of reshoring or building out value chains in Canada for your products.
Yep. So this is actually a very big question. But anyway, I can share a little bit of my personal opinion and my observation. First of all, on value chain establishment, it's actually quite a new stage for everyone. For example, before that, actually a lot of people rely on the production in Asia, and right now I don't think it's not anymore, or at least people trying to change that. So recently we have a lot of requests from customers that, hey, can you build this in Taiwan, or can you build this in North America, because we want to make sure that the value chain is intact and good in North America. So all those kind of questions are actually flying everywhere, especially a lot of potential customers in North America. They used to buy products from China, and right now they are looking forward to find a good producer if they can produce in North America. Things to be said, overall, I think Canada, as an investment environment, we have a lot of things that we can work together, and we definitely need a lot of help. For example, there are things that will help people to choose. It's not only raw material that, of course, as a bioindustrial company, we need to find good raw material source. For myself, I'm looking for cheaper sugar from corn, or actually vegetable oil locally, stably. Those kind of things will help us to really make a decision where to go. Other things like regulatory approval, those kind of stuff, and not only on our production, but also in the product. Things like I have mentioned, like how does Canada treat, how is the policy treat those one-time use plastic? And also how does Canada treat our fermented product, which will be a new process, but it's going to be safe and it's going to be good, but it's new. How does Canada look into this kind of information and really react and accept some new things? And of course, we are going to do a lot of tests and stuff and make sure they're safe. But then how are the regulatory and other sectors that can help us to accelerate this process? There are some countries that fortunately they are very open to new things, like US or other country. They will be more open to, for example, their FDA are very quick to approve a lot of new products we are doing. Those are the things that will affect the value chain you are mentioned, and to affect the production in Canada. Those kind of all are very key elements. And sorry that I cannot cover everything, but they actually interact, and you have to consider them all.
Dex, I think you hit a lot of buttons on that one that we share and talk about across Canada. So I think that was a very, very good summary of a number of the issues that we hear about and we heard about as we went across Canada to develop the industrial bioeconomy strategy for Canada. So thank you very much for that summary, because I think you hit a lot of high points there. And I think that leads very nicely to the next question that I have here, and it's I'm going to read it because it's well written here. Given its diversity of forestry, agricultural, municipal solid waste, algae, etc., the industrial bioeconomy does not have a natural home in Canada, does not have a political or bureaucratic champion, and as a result, is not high on the federal government's agenda as part of the green and just recovery. How can we address this challenge so that the industrial bioeconomy can help Canada meet its Paris commitments? So that's a pretty deep question, and I think I'm gonna go to Bill and Stephane, whoever wants to take that one on first. The other will have a little moment to think.
Okay, yeah, that is a good question, and you know, I often think about the agriculture sector. We're kind of we're a humble industry at times, and we don't always talk about the contribution that we make to the Canadian economy. I started off some of my comments level setting the agriculture sector. We are Canada's largest contribution to jobs in Canada, second largest contributor to GDP. I think we're getting a little bit better at talking about the benefits of the sector. I think COVID-19 has certainly raised the profile and the importance of primary agriculture and value-added processing in the country. I think we need to do more. I think for the agriculture sector, for me in particular, we are not an extractive industry. We are very much a contributor to Canada's green agenda, to our carbon sequestration goals, to the work that we're doing to meet Canada's commitments on the global stage around contribution to climate change. We just have to do a much better job of telling that story and talking about it. And I know the agriculture sector has been saying this for a long time, but I think as we think about back to my talk, the evolution of Canada's agriculture sector contribution to the bioeconomy changing dramatically from where it was even 10 or 15 years ago to what we think we can do today. We've got a much more holistic and better story to tell. And so I think we do need to do that. And I think the other thing that's adding to that is the growing global demand for food and the changing consumer dynamics, people wanting sustainable food sources, nutritional food sources, really worried and thinking about the impact that their food choices are having on the environment. The time is right in terms of increasing the profile of the sector in Canada.
Stephane, I'll go to you.
Yeah, I appreciate Bill giving me a bit of time to think here, because that's a interesting question with multiple angles. So listen, I think if I try to simplify it, at least in the way I'm thinking about that question is, if you look at government, province, federal, other agencies, we have a high level of complexity, and getting the right assembly of players to work together to get the right project to advance across the bioeconomy, which we need all those players to work together. So I think I'll just come back to a couple of comments that were made through questions here. Policy and procurement are the key tools that will pull everything together. It's by creating that lower risk, by creating this pull and this environment for investment that will get there. I think the amount of programs or different players that can play is interesting and complex, yes, but if risk was lower for capital to be invested in the bioeconomy, we'll be in better shape. The bottom line is, if you have 100 or 200 million to invest in Canada today, will it be an agriculture side or forestry side? What will you do? You will invest in Canada, or you go to another country when you have a different climate for investment? I think that's a question we need to ask ourselves. We have great regulation in Canada to protect the environment, etc., and I'm a big supporter of them. Is what do we need to add to that to have the complete package so investment and driving the markets become a priority for all and an opportunity for all the investors? I think that's how we answer this. And if we do that right, then we can dream of getting better on Paris Agreement or Kyoto rules and etc. We can get there. But having the right climate and the determination to have all the piece of the puzzle from a policy and environment perspective, that's what we need to get to.
Great. Thank you very much. I'm going to draw in Joop and Dex into this, but I'm going to change the question a little bit and ask you to give us a bit of a perspective of what's happening in the areas of the world that you're most familiar with. For Joop, it's Europe, and for Dex, it's Asia. What are those areas doing that we could learn from here in Canada? I'll start with you, Joop.
Yeah, so you know what I think is working quite effectively over here is to make a flow down of, you know, what are the marks that we need to hit in terms of, for instance, CO2 reduction. And then, you know, break it down by, okay, this is what we can do in the energy world, this is what we can do in the built environment, in the transport, in the industry. And for us, that has pointed out that there's quite an important role for circular and bio-based, and you know, moving away from petrochemical sources. Now, related to that, what I think is important, and I do see some change in there, is not to get paralyzed by you know, the overwhelming position of the petrochemical industry. I mean, it's been optimized over more than 100 years, and makes me think a little bit about a small anecdote. It's not too long, Sandy, if you allow me. I think in Canada you have bears, right? There were two guys running away from a bear, and pretty soon they got tired, very tired, and the one with the worst condition said to the other one, you know, it doesn't really make sense to keep running from this bear, because ultimately he will be much faster than we are. But then the other guy replied and said, well, I'm not really running away from the bear. I'm just outrunning you and I'll be safe. And, I think that's an important way we could think as well. The petrochemical alternative, there's a lot that can happen to it. Oil prices can go in directions that they have been not too long ago. But also you can think, okay, what if that is just no longer an alternative, because we cannot afford to see that as an alternative anymore? Then it's not so important, whether you really beat the petrochemical alternative, but the most important thing is, are you the next best alternative? And you could make a parallel for other, let's say, old-fashioned technologies as well. So, you could look at plant-based proteins. Are you the next best alternative for meat-based proteins that are certainly not so environmentally friendly?
Great, thank you very much. Dex, do you have a perspective from your European experiences, or your Asian experiences, excuse me?
Yeah, but yes, because I'm from Taiwan, but to say the truth, if we are talking about the bioplastic, everyone is talking about in Europe. But because right now Asia is actually looking for what? We are looking, Asians are looking after European and North America, how these countries are going to do that, and they are going to follow very quick. So let's see. It's a leadership stuff in this world. But anyway, here's my observation, but it's not necessary to be right, as I just mentioned. This whole bioplastic stuff, because it's late development, so you definitely are going to lose in scale compared to petrochemical. They are producing in multi-million tons per year. It's impossible for you to compete cost with them. It's almost impossible, even though you have the best technology in the world. So what happened is that you need to put this into a very high level thinking. You are not only producing plastic, you are actually doing something that actually will be good to the environment. That is the major thinking. But unfortunately, most of the end consumers, they don't think this way. Okay, there are brand owners, for example, $5 coffee. They can very easily to advertise and branding to their end consumer that, hey, by paying $1 more, or no, not $1, 50 cents more in your coffee, you can save the world. You can save the turtles in ocean. Most of people who has already paying $5 of coffee will definitely take that route because they want to save the world. Other than that, but that is actually a considerably small portion of the market. Other than that, you need the government and the regulatory kicking and really to help you. So the reason why European countries are very quick and they are already doing something. So right now it's almost a year has passed since the European Parliament and the European Council adopted the so-called Single-Use Plastic Directive in summer of 2019. So in order to comply with this Single-Use Plastic Directive, member states have 2 years to bring into force the necessary laws, regulation, and administrative provisions, and the deadline ends on July 3rd, 2021. That's the reason why a lot of attention drawn into polymers like PBS and then building block like succinic acid. Because right now government in Europe is really looking to the possibility that we need to deal with this environmental issue and we need to find new technology to deal with it. So for the brand owners and the end consumers, first of all, this is a good advertisement. And second thing is that because of this, this is a new act, they are thinking that, okay, this is not only doing good to the environment, the most important thing is that maybe after 2021, July 3rd, I cannot use polypropylene-based paper cup anymore. So that's why they start to find new solutions and start to adapt PBS into their product. They want to act faster before you cannot do anything. And that is something that if you look back to Canada, that actually we need to think how do we adapt all this, because once these things happened in North America, then the market in local area will start to bloom. I see some text Q&A here said that, hey, it's actually very interesting that you produce succinic acid here, ship to Thailand, ship to Asia, make PBS, and then ship back to Europe. That is not ideal, but that is where the market is doing. So this is just my observation. It's very interesting, but actually highly related to your the question you asked.
Great, thank you very much. I'm going to shift a little bit to Stephane talked a little bit about carbon sink or carbon sequestration, and the bioeconomy has a tremendous potential, and Canada's bioresources are the envy of the world. But for these assets to be a clear climate solution, we need to ensure that these carbon pools are managed and leveraged effectively to sequester carbon. I'd like to expand on that a little bit, particularly as it relates first on forestry with Stephane, and secondly on agriculture and the potential for measuring carbon sequestration or carbon pools there, and how can we do it? What should we be doing in those spaces? And then I'll also go back to to the other panelists to get a perspective of what's happening elsewhere. So to you, Stephane.
Okay, this is an important topic, and I think there was a question also on the Q&A that was asking, so what's happening in Canada there? There's actually a lot of people involved in carbon accounting, trying to understand pools and sinks and how to calculate life cycle analysis and carbon. I think we get a note to the work done by NARCAN, the CFS in the Pacific labs, which is tremendous, right? We can kind of lead those type of analysis actually, so it's good. The accounting though come with rules coming from the Kyoto Accord, and it's not helping necessarily the prime producer in forestry to be accounting for carbon sinks. That's not in part of the equation. So that's aspect A. Maybe I'll just answer that question, Sandy, with an anecdote. So us two went to the end user at some point, and we reached to the big brand owners of packaging or a product and asked them what they really think about and why are they interested in biomaterials. And it was phenomenal to see how advanced they were in Europe, especially in terms of thinking about my packaging need to have the right life cycle analysis. Their carbon footprint need to be lower than what I have. And they wanted to come to Canada to work with us because our forest is managed better than everywhere in the world. So in their LC analysis, the numbers were better. So it's there. We just don't recognize it as much as we do, and we don't monetize it as much as we should. So huge impact, but again, there's got to be either a market pull on it, a monetization possible through a carbon tax or whatever other economical mechanism, or regulation. It's there. We actually got it on the forestry side. We have one of the best managed forests in the world. That's how I'm going to hand it.
Thank you. Bill, agricultural's perspective on this.
Yeah, so if you think about, and so I'm most familiar with the province of Saskatchewan, but I think this probably extrapolates to most of Western Canadian agriculture. I don't know that it would extrapolate to central Canada, but if you think about the greenhouse gas emissions from agricultural production, it's, don't hold me to these numbers, but it's about 50% crops, 50% livestock. The crop is generally from the gassing off of synthetic fertilizer, and livestock is methane and manure decomposition. But the vast majority of our emissions, and there is also some related to transportation of agricultural commodities, but really not very much. But most of that is offset by carbon sequestration as a result of zero till, and the work that our producers are doing to retain carbon sinks in the soil. And the carbon sinks in agriculture have been increasing ever since the adoption of minimum and zero-till in Western Canada, going back to probably the mid to late 1980s. And so, you think about the equilibrium that we've hit in terms of carbon sequestration and greenhouse gas emissions from agriculture. As a sector, we're approaching equilibrium. Now, I know that there's a lot of debate out there in terms of the science of how we are measuring and managing this. So one thing I think we could do, Sandy, to your point, is to do a better job of measuring both inputs and outputs in agriculture, so we really have a sense of what the contribution is, net positive or negative, and then design some policies around that. But that's the state of today. I think as we look to the future, we've got a lot of opportunities to further reduce agriculture's footprint by getting a little bit better in terms of placement of fertilizers and diets in cattle. And so there's a lot of technology coming that I think will help tell the better story. And then, of course, the follow-on is the contribution that agriculture can make to the bioeconomy and the green economy by the transformation of co-products to offset some of the products that we have today that are derived from fossil fuels.
Thank you, Bill. And just to follow up on your own comment, I think your comments about no-till or low-till agriculture is happening in Eastern Ontario, or is happening in the East as well. And I think the same trends you've talked about are there. It's just the ecosystems are different because of climate and soil and so on. But I think the same trends apply, at least based on the things that I've heard from the agricultural experts that I speak to here. So, Joop, where are the Europeans on forestry and or carbon sequestration through forestry and agriculture?
Yeah, first I would like to say, Stephane, I won't tell your quote to the Scandinavians about the Canadians being better in forest management, because they will come and hunt you.
We talk often, don't worry. They are pretty good as well.
But yeah, like Sandy said, it's very local in terms of climate, vegetation, soil. What are the issues at hand? And I must say, here in the Netherlands, we hardly have any wood, so people have a very hard time even grasping the concept of sustainable forest management. Here, people are saying, "Thou shalt not kill a tree," which is very confusing to me. But one interesting aspect that also plays a role here, I think, is carbon capture and utilization. So we see some very large initiatives in using CO2 as a feedstock, and, for instance, electrochemistry as a technology coming up there. And really, if you go to the source of sustainable electricity, some very different business models become available, and can be very sustainable way of producing feedstock from CO2 as or even methane. So we see some major initiatives in that direction to just add a very different perspective to this.
Great, thank you. Dex, do you have anything to add to this?
No, I think I agree with you guys, and I'm learning a lot as well. Thank you.
Great. So interesting question I have here about scale, because clearly this panel has been focused around significant biomass sources that we have in Canada based on forestry and what I'll call commodity or large agriculture that we have in the prairies. The question here is, when you get outside of the prairies in agriculture or forestry, what are some of the key drivers for the development of bioeconomy projects on a smaller scale than you would see in the forest or in Western Canada? How do small-scale industrial projects participate in the bioeconomy? For example, is the bioasphalt opportunity based on large volumes of available biomass, and is it suitable or available to be done on a smaller scale that can work in some of the other geographies that we have in Canada. I'll let anyone start with that that has a comment. If not, I'll start with you because you know, you've got lots of population, but a lot of your biomass sources are more localized and not as massive as we see in some of the regions of Canada.
Yeah, sure. I'd like to make some comments to that, Sandy. I think there's some different ways of looking at smaller scale successful activities. One is, and there, if you look at the asphalt, you know, as an example, that's typically an industry where you have fairly small asphalt mills or you know, factories that service a circular around them. You know, that's maybe something like 50 to maximum 100 kilometers, just by the nature of that industry. Transporting warm asphalt from the plant to the site where the roads are built. So that makes sense to use relatively modest scale. But another area where smaller scale activities can be very successful is more the high end, you know, the niche markets, the higher value added. And there we see, for instance, one example in the Biohorizon initiative, where we create through this furan deals all the chemistry, highly functional bio-based aromatics. Like, for instance, if you put 3 acid groups on a benzene ring, that's quite a special product. And you can build a business case with a 50 kilotons plant that is successful. You may argue that maybe the impact on CO2 emissions is also modest if you go to these smaller scales. But it does give a financially attractive model. And I think it's also a way of growing into larger scale initiatives. Usually, I mean, I see all these attempts to beat phthalic anhydride and you know, polyester. That's very tough. One reactor for them is 2 million kilotons a year. So, you know, how are you going to beat that with, for instance, a 50 kiloton size? So going for niche and high value add can be a nice way to grow and learn.
Great, thank you. I'm going to go over to Bill and then to Stephane.
Yeah, thanks, Sandy. I think maybe to just build on what you had said, it probably becomes the inflection point between value and scale. So I look at what we're trying to do at Protein Industries Canada, you know, converting 60 million metric tons of crop production, extracting 14 million metric tons of protein. Those are processing facilities at a larger scale than we're talking about. But at the end of the day, you know, that graph that I showed about moving up the chain in terms of purity of starch and fiber, there probably is opportunity for smaller regional type processing facilities producing higher value products. And so to me, it just becomes a question of, you know, volume versus value and finding the right inflection point for some of these types of facilities. It won't be a question of access to the product as an input. It's a question of can you make it profitable at a smaller scale for a smaller regional type facility.
Great, thank you. And Stephane?
Yeah, no, it's interesting. Small scales and large scale. I mean, typically those have actually different engineering solution, and that's part of the challenge. If I take, for instance, all the biofuel world, let's take that for an example. It's a completely different problem if you're in the region, you're trying to displace diesel and the cost of transport of diesel to produce a biofuel locally. That's going to be a small scale technology, will be viable if you're up north in BC, for instance. Several good technology are good for that. If you go for much larger scale, you go in much larger plant, LNG plants, Fischer-Tropsch process that are $500 million investment typically. And that's a bit of the challenge, right? Starting small and grow up, it depends on the technology and the market you want to displace. And if you really want an economy of scales and try to inch at beating the incumbent, it's going to need that large scale investment at some point. So what's your path towards that? That's part of the challenge we're having in technology. I cannot demonstrate a large plant for RNG or LNG or etc. will be viable from biosource unless I prove the small parts one per one, which are not product in themselves. So bit of a challenge there.
Very good. And I'll go to Dex now. We're just going to wrap up. This will be our final piece. Dex, you know, the BioAmber built a fairly significant plant there in Sarnia and ran into some challenges. You now have taken that plant and are building it out. Do you have some comments about scale and particularly as it relates to the assets that you're operating in Canada?
Okay, so the question is about this scale. Fortunately, this Sassini asset plant, if we really do it in full capacity, it's 30,000 capacity, 30,000 ton per year of capacity of bio-Sassini acid, which to use, it's actually the biggest plant in the world because other plants are actually under 10,000 ton per year of producing capacity. So it actually has a lot of potential, but actually the real challenge is in the market. What BioAmber faced is that they're actually a good company. This plant is designed very well and the technology is good. Everything's going well, was going well. Actually, the only thing I think we need to pay attention, and it's actually the major shortcoming, is the timing. Right now, we actually in a better position simply because of some regulatory changing in Europe. And also we have a consortium with our customer and also customer's customer. They are brand owners. What they're trying to do is it's the two stories that I just shared. They are selling $5 coffee already. So they are willing to pay more to support green plastic because they want to contribute this to this global issue. And also they think this is a very good brand name to their consumer, to brand their, to be a branding to their society. So right now this consortium has a simple target that we do only a little bit ahead of the regulation. And then we use bioplastic and biodegradable as a branding. And that is the true story that we are doing right now. And we only can do this with the premium price. And in the end, we will grow these plants gradually to larger scale. But that is the only thing you can do. I think most of the bioplastic, when you are small in scale, like you have to form a plan like this. I'm not successful right now. We are doing everything we can. We are getting much better than before, but still a lot of challenge ahead. So that's one thing. Another thing that I want to mention that it's actually a totally different example compared to Sassini acid, which we are able to produce here is our biocarotenoids. It's going to be a different story because A, this kind of product is very high in value already. This one. B is that it's actually not like a green plastic that you need to work very hard to compete with petrol, because if your applications are food, nutrition, animal feed, this kind of market, your consumer like nature process already. So this time when we are marketing this product, we really simply see our customer, they are eager to switch from petrochemical related product to green process. So at this moment, we will have for this kind of biocarotenoids nutrition product. Compared to Sassini acid, we actually got a lot of support from customer. And that is actually another example that regarding to growing and the small scale to large scale, that the product itself have to make sense. Just a share of what we are looking at right now.
Great. Thank you very much, Dex. And I think that is a very, very appropriate way for us to wrap up this this conference, or this 2 hours. I think there's three things that kind of pop to my mind as I try to think about what we've talked about here. You know, this whole concept of innovation and technology development and scale, and how to do that and how to bring that across, I think has been well talked about here, and there's a lot of effort being done in that area. I think certainly in innovation, Canada is doing a great job. We're focusing now on getting better at scaling, but as you can recall from the conversations and questions, that is very difficult. But I think the market piece that Dex talked about at the end is the piece that we've got to continue to get our focus around, is building the markets and getting our products out into the markets and being able to provide that competitive advantage for our products so that we can gain the value needed out of our products to be able to make effective, profitable businesses. And clearly there is, in this emerging area of the industrial bioeconomy, there's a role for government to play. It's been talked about. Regulation, procurement policy is all really important, but it also is, we're on a path to reduce our carbon footprint and meet our climate change targets. The bioeconomy has a way to do that, and BioDesign and all of our groups here look very much forward to working with government to do whatever we can to progress this forward. And as final, I really want to thank our speakers. I thought the panels were excellent, and I appreciate the questions and the openness that you had to the conversations and questions that came in. Before I close, I want to recognize our BioDesign partners, Bioindustrial Innovation Canada, FPInnovations, who were directly involved in the panel here today, as well BioNB from New Brunswick, Forestry Products Association of Canada, and Biotech Canada. This group has been working very hard over the last few years to progress the industrial bioeconomy forward and keep it front and center. We will continue to do that, and we look forward to partnering with those who can help. I also want to thank our supporting sponsors for the conference, Lambton College and the Sarnia-Lambton Economic Partnership, who've helped us put this together. This is the first day of a 3-day virtual conference. Tomorrow, the topics are, tomorrow the conference will be starting at noon and not at 10 o'clock, so please keep in mind when you're looking to check in tomorrow. Tomorrow's focus will be discussing transforming to a low carbon economy. So that starts noon Eastern tomorrow. But then on Friday, we will be back to 10 o'clock Eastern in the morning for the final session. We did move tomorrow's back 2 hours to basically not conflict with a partner organization we are working with in Europe. So that is why it's moved back 2 hours. So I think I've got that out there. So 12 o'clock noon tomorrow. Look forward to hearing that panel and some more very interesting conversation and discussion. So with that, I will close and thank you everyone for participating today.